aim of DC4 within the Serenade project is to develop this mini GC-MOS device with temperature modulation in the detection. And we want to try different columns, different designs for the oven where we put the column. We want to test different metal oxide sensors, also different modulations. So to try all the possible different possible configurations that we can have for the components of this mini system. And at the end, what we want is a product that is that can be used in loco, for instance, in a supermarket, that is portable, so that I can carry, and having a targeted food, I can using the VOCs that are released by this food, then proper estimating a time interval for food safe consumption, so measuring the shelf life of food. Here we combine advantages of both gas chromatograph and metal oxide. So in a gas chromatograph, we have a nice analytical instrument for separating all the different compounds that we have in an analyte. And then with the metal oxide sensor, we have a high sensibility detector that has low capabilities for selectivity, so low selectivity. But this is not a problem. Also use a gas chromatograph prior to the detection. So that's why we combine both. What we want so is to take this instrument that is kind of bulky, as you can see, and just miniaturize, but preserving at the same time the rigorosity and the capabilities of gas chromatograph. So the impact is having this miniaturized instrument that has the strength of having the separation of the VOCs compounds released by the targeted food, that then enable a strong study by the data that is generated by the detector, the metal oxide sensor. Because in the metal oxide sensor, we have a high sensibility but a low selectivity that is then, let's say, improved by the prior separation in the GC. What we have now are systems, lab systems that are kind of bulky, as we have here in the lab. So this analytical GC for lab measurements and studies. But in local, I mean, you cannot have a bulky device, so you need something that is portable and at the same time with a low consumption and also with a price that is not that high. So that's why we use a metal oxide sensor with a cheap, so this is a cheap detector and a high sensibility one. So within Serenade project, we have the DC7, DC6. The collaboration is pretty important. For instance, on my side, to combine the data from DC1 and 2 and having the microbiological perspective of the degradation and spoilage processes that happen in the targeted food that we are analyzing, foods that we're analyzing. So from my side, this is very important in order to build a robust model together with the mini GC-MOS device.